Salam sejahtera to Mr. Muhammad Maswan bin Mahat. Today, our group would like to present our research based on the virtual industrial visit of the company Heavy Plus Sdn Bhd, manufacturers of plastics and rubber extrusion products. So we are from class M1B. This is the contents of presentation. The first is introduction of the company, number two is findings, discussion, and lastly, the continuous quality improvement. This is the work distribution and the members of the group.
Assalamualaikum. My name is Aisha Safira binti Abdul Rashid. I'm going to introduce the company that we choose, which is Hivoplas Sdn Bhd. Hivoplas Sdn Bhd is a manufacturer of plastic and rubber extrusion products and was established in 1988. It has 33 years experience in extrusion manufacturing to innovate new manufacturing and design of precise tooling. The company is also specialized manufacturer and agent for customized plastic and rubber extrusion with certified ISO 9001 edition 2015. The company also provides a wide range of products with the option for customization and research and also development collaboration with catering to all industries, be it automotive, medical, construction, furniture, consumer good, electric and electronics, and many more. This is some of the country that Hivoplas Sdn Bhd covered.
So I'm MEM560, so I will share about our finding on our to the company name Hivoplas. So the first finding is about the manufacturing process in producing PP corrugated sheet. So there are 4 processes that we found. The first one is extrusion, second vacuum calibration, third die cutting, and the last one is color printing. The first, let me see to the extrusion process. So this picture show us about the extrusion line. So you can see it has extruder, cooling system, cooler, and die cutting at the last. So material which is recycled plastic pellet is pushed through a die of the desired cross section. And the next process is vacuum calibration process. So vacuum calibration is performed to verify that PP corrugated sheet are providing accurate vacuum pressure movement. Regular calibration will ensure the repeatable accuracy by comparing the measurement produced by the PP sheet with that of a standard or allowable tolerance. The next process is die cutting process. A die is used to cut through the PP corrugated sheet. This process allows the company to make an identical cut into the product numerous times. Custom-made blade is used to cut the PP corrugated sheet, which is a suitable blade. So this picture shows this die cutting process. The last process is color printing. Color printing only been done if we want to make an advertising board from the PP sheet. So it use blocking stencil on a fine silk mesh. Ink is then squeezed to transfer the stencil design onto the PP sheet. It is dry under the UV light to lock in the color. So this picture shows us that advertising board from the PP sheet. The next finding is technology employed. So we found that technology employed in this company is the main technology employed is PP corrugated hollow sheet extrusion line, which include 3 things. The first one is extruder, second mold, and the third is vacuum calibrating system. So extruder. So the extruder machine has advantage of high capacity and a strong plasticizing ability. It can make high quality of PP hollow sheet. So this is extruder machine. The second one is mold. with advantage of high quality, easy operation, uniform material flow, and stabilize production. Our PP hollow sheet mold can be 2 until 6 mm thickness of PP hollow sheet. So this is mold machine in the company. Last one is vacuum calibrating system. The vacuum calibrating system in this company is adopting self-correct vacuum cooling system. It can achieve high speed production, and it also can achieve operational safety, and it is easy to calibrate our machine. Next, we move to design concept. As we can know, this PP sheet, it is lightweight, non-toxic, waterproof, shockproof, long life, corrosion preventive material compared to cardboard. It is an ideal material for packaging, advertising, construction, and agriculture use. It is hollow structure, and it is for make it lightweight, but it is strong enough to support the daily equipment such as book, kitchenware. Okay, so this is the design concept. The next, we move to quality assurance, or we know as QA. So in order to produce a better and a good quality of PP sheet, this company has list 4 quality assurance that they need to approve. First one is water resistant of the gluing. Second is box compression test. Third is puncture resistant test. Last is scuff resistant test. So we see the first one. The first one is water resistant of the gluing. It is to ensure that the PP sheet adhere well even in moist condition and exposed to water. Box compression test. Box compression test measure the compressive strength of PP corrugated sheet. It provides a plot of deformation versus compressive force. It has been done to produce a PP sheet with suitable compressive strength, as you can see from this picture. Okay. The next one, as we can see from this picture, it is puncture resistant test. It has been done by measuring of the maximum force or energy required to penetrate the PP corrugated sheet. It is to produce a better relative ability of the PP sheet to inhibit the intrusion of a foreign object. The last one is scuff resistant test. It has been done by measuring the permanence of the PP sheet to resist abrasion, or as we know as a scratch. It is to improve the quality of the PP sheet. So it is 2 findings that I list. That's all from me. Thank you.
Next is the product produced by the company. The product that we choose from the company is PP corrugated sheets. Corrugated polypropylene sheets, also known as twin wall sheets or multi-wall sheets, are durable and lightweight. It produced in a continuous extrusion process. PP corrugated sheets has the characteristic of heat resistant, fire resistant, wear resistant, impact resistant, and corrosion resistant. The main formulation of PP corrugated sheet is polypropylene. Normally, it is a mixing material of foam polymer and copolymer. To save costs, manufacturers often add fillers and recycled polypropylene.
My name is Saiful Harith bin Alanan. Next is the problem faced by the company. Making injection molded prototypes is both an art and a science. High levels of technical expertise and attention to detail are required to prevent small mistakes from costing companies big money when it comes to mass production of novel parts. Preventing such a circumstance is all about highly competent design. So, I will share some of the molding defects that can occur in a part during injection molding. First defect that can be occur is the vacuum voids. Vacuum voids are pockets of air trapped within or close to the surface of an injection molded prototype. Vacuum voids are often caused by uneven solidification between the surface and the inner sections of the prototype. This can be worse when the holding pressure is insufficient to condense the molten plastic in the mold and thereby force out air that would otherwise get trapped. Voids can also develop from a part that is cast from a mold with two halves that are not correctly aligned. Second defect is the sink marks. Sink marks are small craters or depressions that develop in thicker areas of the injection molded prototype. When shrinkage occurs in the inner portion of the finished product, the effect is somewhat similar to sinkholes in topography, but caused by shrinkage rather than erosion. Sink marks are often caused when the cooling time or the cooling mechanism is insufficient for the plastic to fully cool and cure while in the mold. They can also be caused by inadequate pressure in the cavity or by an excessive temperature at the gate. All else being equal, thick sections of the injection molded part take longer to cool than thin ones and so are more likely to be where sink marks are located. The third one is burn marks. Burn marks are discolorations, usually rust color, that appear on the surface of the injection molded prototypes. Burn marks are caused either by the degradation of the plastic material due to excessive heating or by injection speeds that are too fast. Burn marks can also be caused by the overheating of trapped air, which etches the surface of the molded part. The next one is flash. Flash is a molding defect that occurs when some molten plastic escapes from the mold cavity. Typical routes for escape are through the parting line or ejector pin location. This extrusion cools and remains attached to the finished product. Flash can occur when the mold is not clamped together with enough force, which allows the plastic to seep through. The use of molds that have exceeded their lifespan will be worn out and contribute to the possibility of flash. Additionally, excessive injection pressure may force the plastic out through the route of less resistance. The last one is flow lines. Flow lines are streaks, patterns, or lines that show up on the prototype part as a consequence of the physical path and cooling profile of the molten plastic as it flows into the injection mold tooling cavity. Usually, flow line defects are caused by the varying speed at which the molten plastic flows as it changes direction through the contours and bends inside the mold tool. They also occur when the plastic flows through sections with varying wall thickness or when the injection speed is too low, causing the plastic to solidify at different speeds.
Next, me Ziad Benzari will present about the discussion. In manufacturing a product, the manufacturing processes used need to be researched thoroughly based on the suitability of the product. Next, I will compare the manufacturing processes used in this particular company. Extrusion is more suitable for plastic production, meanwhile casting is more suitable for aluminium production. Die cutting uses less material, so less material is wasted around the shapes than with other cutting methods. It is also cost effective. Meanwhile, digital cutting uses high energy consumption and is not suitable to be used in manufacturing the product. Next is overcoming the problems. For the defect of vacuum void, we can switch to a less viscous plastic. This will ensure that less gap is trapped as air is able to escape more rapidly. For sink marks, mold temperatures should be lowered and holding pressure should be increased. For burn marks, we should reduce the injection speed. To overcome flash, we can ensure that the mold is properly maintained and clean. For the problem of flow lines, we can increase the injection speed and pressure to the optimal level, which will ensure the cavities are filled properly. Next is the other product produced using the manufacturing processes. For extrusion, we can make pipe or tubing and deck railings. For vacuum calibration process, all sorts of polymers product could be produced. For die cutting, tissue boxes production and birthday cards. And for color printing, color photographs can be produced.
Okay, so this is continuous quality improvement, CQI. CQI is a quality management process that ensures the capabilities of the product to always meet up with all the specific conditions. It also helps us to understand the nature of the product that serves its purpose. In this process, we always ask ourselves about what are we trying to accomplish and how will we know that a change is an improvement, and then what change can we make that will result in improvement. So there will be 4 steps in this process. The first one, which is act. In this step, we will revise the manufacturing process and material use as we recall the details of the manufacturing processes and comprehend its pros and cons. We also need to re-evaluate the material used, whether it's enough to serve the quality of the product to its maximum potential. The second step is plan. In this step, we are developing new ideas for the manufacturing process and material use. After the revision, new idea will be implemented to increase the efficiency of the manufacturing processes and the material used for the products. The ideas will be discussed together to select the best of them. We go on to the next step, which is study. In this step, we are reviewing the feedback from the employees and customers. The feedback will be resonant with the idea plan. There will be research that will be conducted to acquire more outstanding ideas for the quality improvement. And the last step is do. In this step, all the evaluation, discussion, and planning will be added into the working line of the company as the basis of the quality improvement. That's all from us. Thank you for watching the video.